Hi, I'm Valentina Marturano and I am a researcher at the Institute for Polymers, Composites and Biomaterials of the Italian Research Council. At my institute, we study the environmental impact of conventional plastic materials and we design new and more sustainable plastics. In this presentation, I will talk about some of the environmental benefits of bio-based plastics. Then I will show you how these sustainable materials are ready to successfully substitute conventional plastics in some applications. And finally, I will talk about life cycle assessment, LCA, an effective way to evaluate the sustainability of a product or a process. As you probably know, petroleum-derived plastics are all around us, so much so that we cannot live without them. Plastics are in our house, in the car we drive or bike, and even in our smartphones. As we learned in the previous units, a new class of plastic materials is now rising, defined as either bio-based or biodegradable, preferably both, and they are rapidly displacing conventional plastics in some single-use applications. We are speaking of bioplastics. Of course, it would not be possible to massively substitute all conventional plastics at once, because some applications require properties like toughness, chemical resistance, or flexibility that newborn plastics may not have yet. The goal is to evaluate case by case if a product can become more sustainable if bioplastics are used. One simple example is mulch films. Huge black plastic sheets used to protect crops from weeds and keep the moisture level high in the soil. Commonly, mulch films are made of conventional plastics, mostly polyethylene, which are cheap to produce, easily placed, and very resistant. Their end of life is, however, limited to landfill, burial in soil, or burning, rarely recycling. These are not very sustainable options, so there is an urgent need to replace them with more eco-sustainable alternatives. Biodegradable mulch films have been proven to reproduce the same effect on soil as their polyethylene counterparts, and once removed, they biodegrade, becoming fertilizer for the same soil. This property is a great advantage, uh, not only from an ecological point of view, but also from an economical and organizational perspective, conferring added value to the inside disposal procedure. Let's think about rigid or flexible food packaging also, currently made of petroleum-derived plastics. Food packaging is not easy to recycle because food contamination hinders the sorting process and makes the cleaning step extremely difficult. Moreover, each packaging is designed to maximize the quality and the freshness of the packaging food good. For this reason, different plastics are sometimes coupled and metallized layers are inserted to obtain multi-layer packaging. As you may have guessed, this has a huge disadvantage. The packaging becomes not recyclable because the different layers are not separable. So at the end of its life, when you actually eat the snack and throw away its packaging, this will end up in landfills or waste-to-energy implants. Compostable bioplastic could effectively substitute rigid and flexible packaging. They would simply be disposed of in the organic waste, together with food residue. Another example are single-use conventional plastics, like disposable cutlery, cups, and plates, which are often used outdoors, for example during picnics with family or friends, and they can escape the recycling system. These items are among the 10 single-use plastic objects most found on Europe's beaches. They are not biodegradable, so they will remain in the environment for a very long time, and they will pose a threat for living organisms. The EU is promoting the use of biodegradable alternatives. Even if biodegradable cutlery, cups or plates are dispersed in the environment, they will soon be transformed into simple molecules and biomass, thanks to the combined effect of weathering and microorganisms. Moreover, conventional plastics can be replaced by bioplastics in aquaculture application. Over 600,000 tons of abandoned or lost fishing equipment, such as fishing nets, traps, and longline, enter the ocean every year. In the same way, plastic commodity items such as toys, beach equipment used by family can be unintentionally dispersed in the marine environment. Conventional plastics in this condition can be corrupted and consumed by physical agents or silent corrosion and can release microplastics. By engineering new bioplastics able to biodegrade in the marine environment, we can mitigate microplastics pollution and minimize their environmental impact. Life cycle assessment can help us to evaluate the environmental impact of plastic products from cradle or from the raw materials to grave, which is their end-of-life scenarios. LCA attributes to each step of the product's life a CO2 emission, from raw materials extraction and processing to manufacturing, distribution, use, and finally recycling or disposal. For bioplastics, the first and last step of the LCA highlights their environmental benefits. The raw materials used to produce bioplastics are plants that during growth significantly contribute to carbon sequestration during their photosynthesis. At the end of the product's life cycle, it biodegrades back to simple molecules and compost materials used as fertilizer for other crops, indeed starting over a new cycle, achieving a thriving circular economy. To sum up, we now understand how conventional plastics cannot be drastically replaced by bioplastics, but we need to evaluate case by case when it's convenient in each particular application. Life cycle assessment of each plastic item can help us make this decision. Thank you very much for your attention. Bye!